You may have seen me talk about slang today and yesterday, but I'm also actually here in my capacity as a member of the Vulkan Safety Critical Working Group. So I'm going to switch gears and tell you a little bit about that. With GPUs at the heart of modern machinery, it's very critical that all workloads are fault tolerant. And if you're wondering why, well, consider the last time you were running a game on a desktop and ran into a driver crash. Usually you have to restart your game. You might even have to restart the PC or game console that you're running the game on. But we can't afford faults like this that could happen if the GPU is in a car or a robot on an assembly line or other embedded applications like that. So we need a graphics API that's designed to run in embedded systems, in a car, in a robot, anywhere. And open API that hardware drivers can implement so that app developers can build their apps across a wide range of GPUs with fault tolerance in mind. So this is the soul of Vulkan Safety Critical, or Vulkan SC for short. I'm going to talk about a few things today. I'll cover how workloads get shared between AI and graphics on the GPU, why Vulkan SC is the preferred solution. I'll walk you through an example use case. Then I'll talk about how you would go about moving to Vulkan SC. I'm also going to discuss where the different perception to AI to visualization use cases are in the industry, and where you can get Vulkan SC today. So the most familiar example of a Vulkan SC use case I can provide for you is an autonomous vehicle or a car with driver assistance. So today, those vehicles need to perceive and visualize an incredible amount of data in real time. Autonomous vehicles can have up to 6 cameras and a LiDAR system and a radar system, all perceiving the surroundings. From your traditional backup camera and your surround view, where the cameras are stitched together to provide a top-down or 360-degree view of potential obstacles, to parking assistants that scan the vehicle surroundings to find available parking spaces, to confidence views where everything that the AI perceives in terms of driving lanes, traffic lights, and your surrounding vehicles need to be visualized in real time at 60 frames per second. And as the AI in the vehicle grows in capability, so will the data requirements and the amount of rich information that we need to visualize. So there are a few ways today of ensuring that the AI compute workload can be safety certified, from isolating it in a VM and then doing the display in a separate VM, all the way to having separate multiple GPUs and having those GPUs communicate via a serializer. The flow is the same in both cases, where all of the data exists in one VM, the one that's doing the thinking. But since the display is not safety certified, it needs to be sent across to the other VM via some sort of inter-VM communication channel like IPC. This can be extremely inefficient due to the available bandwidth on the communication bus, which is small. So not all of the data that's available to the AI can be displayed. And if you think about the surround view, that requires streaming real-time high-definition sensor data from several cameras across VM boundaries, and then deciding which side of that boundary that you stitch them together. With Vulkan SC, you can access the graphics directly inside the safety VM. And the reason for that is because Vulkan SC promotes fault tolerance. It does this in three main ways. First, it guarantees that concurrent workloads between AI compute and graphics can operate without interference. The latest modern GPU designs can even partition GPUs so that graphics and compute work can be done simultaneously, but in isolation. For example, NVIDIA's Hopper and later GPUs ship with this feature. Secondly, they eliminate GPU processing stalls due to dynamic allocations and shader compilation. Vulkan SC does all of its allocations during initialization, and then all the shader compilation must happen offline. You've definitely seen stalls on desktop apps when you hit a new area and a bunch of shaders load, or even worse, if you've seen this happen in embedded apps. It's very difficult to predict when the GPU will decide to allocate memory or when a shader compilation is going to start in GL or Vulkan. So in Vulkan SC, we remove these from the runtime. And then the final way is robust fault handling and reporting. The specification for Vulkan SC has clear guidelines on how faults must be handled. For example, in NVIDIA's Vulkan SC driver, we clearly signal what is a warning versus a fault and the criticality level thereof. In addition, we ensure that the logs are secure and that they don't leak any potentially sensitive information outside of the VM. So Vulkan SC is the driver that you want at the heart of the modern car or robot, or essentially anywhere you're doing work on a modern GPU. With NVIDIA's Vulkan SC implementation, it's unlikely that we will ever jank the screen or deschedule AI compute workloads within the same GPU. This is kind of magic if you consider how we try to do the same thing today in a self-driving car without Vulkan SC. But the status quo today is actually to do GLES for graphics in cars. Mainly because it's easy and there's a large availability of graphics talent out there from mobile apps that already knows GLES. For current vehicles, that might be the right choice. So you might reason, well, why don't I move to GLSC? But the world is accelerating with AI, and graphics should be moving to support AI in all industries. And if we compare the two safety critical graphics, we can see there is a clear winner. So GLSL is designed for safety, but it's not multi-threaded, and it hasn't moved since GLES 2.0, which means that it has no compute support. Shaders for GLSC are also from the GLES 2.0 era, so they're extremely limited in functionality compared to Vulkan SC. On the other hand, Vulkan SC is built on top of Vulkan, so it has zero copy by default. It is multi-threaded friendly, and it supports modern shading languages and features. For example, you can write your shaders in GLSL or HLSL or slang, and they will be supported in Vulkan SC. And on top of that, Vulkan SC supports compute functionality, so it's kind of a no-brainer. So how do you get started writing apps for Vulkan SC? Well, one way to do it is start with Vulkan. After it works on Vulkan, all you have to do is shift your pipeline and shader compilations to be cached using the Pipeline Cache Compiler tool, PCC. Then move dynamic object and pool reservations to static reservation during initialization. It doesn't take much to add Vulkan SC. For a simple Vulkan triangle, it's about 50 lines of code. And then for Lime SC, which is NVIDIA's internal visualization SDK for autonomous vehicles, it takes about 1,000 lines to shift all of the dynamic object and command pool reservations. If you want more details on this, you can get them on the Kronos website. So I talked about one use case, but there's a lot of places where Vulkan SC can help. On the NVIDIA Drive IX platform, we're shipping Vulkan SC for our surround view system. And then in robotic environments, Vulkan SC can help do things like reduce jank for stereo views in remote operation. And then Core AVI has been focusing on avionic graphics and compute acceleration with their VK Core SC product. So you can try Vulkan SC out for yourself today. For Core AVI, you'll want to visit their VK Core SC website for more information. On the NVIDIA side, you can download Vulkan SC for desktop and start developing on discrete GPUs. You'll need RTX 2000 series and up. It's also included in NVIDIA Jetson products and the Drive AGX products. Hammering this point home, you don't need an embedded device to start developing with Vulkan SC. If you have an NVIDIA desktop GPU card, RTX 2000 series or later, you can start today. Just follow that link for more information. And even better, you don't even need a GPU that has its own Vulkan SC driver. Any GPU that supports Vulkan can use the Vulkan SC emulation layer, which we're rolling out. Now, the emulation layer is not meant for production use, but it's good for development, prototyping, and evaluation. But you should ask your vendor for native Vulkan SC support so that you can deploy it to prod. There are a lot of tools and resources to get you started. Obviously the specification is where you'll want to look for all of the gritty details on exactly what's in it. But you can also check out their validation layers just for Vulkan SC. There's a collection of tools and the aforementioned emulation layer, all available at this set of links, which will be available in the slides once they're distributed. And if you have any questions, here are 3 wonderful places to get answers. There's, of course, the Kronos Vulkan SC landing page. And then you can check out the information from both Core AVI and NVIDIA, who are currently providing Vulkan SC drivers. And I believe that is it.